Cloud.
Hello, everyone. Welcome to Practical GCP. So there's nothing actually more important than security in an organization. So today I would like to talk about how to make use of the Google Cloud's IAP service to give you secure and private access to the services or resources you've created in Google Cloud. So this session I would like to cover, first of all, what is Cloud IAP and why it's important, and also followed by a use case on how to apply this on compute engine instances to give you secure and private access. So let's crack on. So IAP stands for Identity Aware Proxy. This is probably one of my most favorite things on Google Cloud. So you can see it as a way that it knows who you are using your identity when you log into Google Cloud. Then you can do a bunch of things using that identity. It actually describes a lot of these things, but I think one thing I would like to really focus on is this area, right? Because this channel is kind of more facing data engineers, software engineers, and analytic engineers. So a lot of you would have been, having a virtual machine or having other services running in Google Cloud, and then definitely kind of very familiar with things like TCP port forwarding. So it's one of those things a lot of the engineers have to do in order to access a service, like it sits within a VM, could be a database, could be other services sits inside the cloud. A lot of the times in the past I've seen people been doing this, the worst ones are exposing public IPs directly into the internet, and then just so they can actually access it from home, especially when people these days are working from home. So that's, is that a right way to do it? Well, you can do it, but it's definitely not the right way to do it. But you still need to kind of be able to access those services that sits within Google Cloud. So this is the one I'm going to specifically focus on how to privately forward the services or do using TCP forwarding of remote services to your local machine. So you actually still do the things you used to be able to do, but in a much more secure way. So you can see IAP is kind of like this, right? So you're a user, and then via the IAP service, you can be authorized to access some of these services, right, inside the Google Cloud. So the one I was referring to earlier is this compute engine scenario. So let's first of all look at a VPC network setup. So the VPC stands for Virtual Private Cloud, if you've not heard about it before. So this is the foundation of the networking setup when if you create any virtual machines inside the service that you need to have a virtual private cloud that you have to put it in there. So the reason I want to start talking about this is when you create a project on GCP, you get given a default network. So you can see this is something I've deleted already because it's not something you should be using, because in most organizations, it's very important you define your own ones. You define your own like private network, your IP ranges, and you can restrict a lot of the things as well. Which gives you a lot more granular control, and it does actually open up the whole, all of these regions which you don't actually need in most of the use cases. In this particular case, I've given a IP range of this is called a CIDR range of 10.0.0.0/20. For kind of a lot of the audience that probably coming from the data or software engineering background, any of the engineers don't actually know what this means. Well, actually myself included from a few years ago, I think, which I had to learn this. So it's actually really important to understand, even you don't actually have the knowledge of a network engineer, but it's still really important to understand what this IP ranges means, how they're created, and what they actually get used in a network setup. So I think the best way to probably explain this is so this is the page I would recommend you read afterwards. But typically you get this different kind of IP blocks, right? If you look at this is from the 10.0, this is the 172. most of you are probably familiar with this because this is what you typically your modem gets at home. But see this as a range that you cannot use on a public network, right? This is designed for private network, so you can't use these for public IP addresses. So the 10.01 is the one that has most of the number of IPs, and it's also the most commonly used in when you use VPC setup. This is as far as I would explain about it. But you can, I think this is actually, it's quite simple to read, so it give you a very good foundation of knowledge of what this actually IP range has been. The CIDR range I talked about earlier was around, this /20. What does this actually mean? It's actually a way to, if you see this as a way to give you a range of IPs, right? Is a representation to give you a range of IPs. The easiest way to actually understand this is there's actually a website which is very useful. What it can do is you can put let's say if you don't understand what this /20 means, right? You put it in and you press populate. And what it tells you is it gives you a first IP and a last IP, and it tells you the total number of IP addresses you can get. You can change these numbers, like say change to 21, and then you can see this reduced to half, and if you change to 22, it reduced to half of that again. So in this particular case, I've used the /20, which gives about 4,000 plus IP addresses. Enough about this IP addresses network ranges. The next thing would be good to look at is to create a virtual machine, right? So you can see that very importantly, I've created this virtual machine. Inside of this network is allocated a IP of .2 in here, but there's no external IP. And this is actually a really good thing. So I think a lot of the default setup in organization is whenever you create a virtual machine, you get assigned a public IP. Not only that can get quite expensive, but also it gives you, it's basically give people the opportunity to expose that service to the internet, which is not something you want to do in majority of the time. So because it's give you the point of people can hack you, right? So with this internal IP, but how do you actually connect to this, right? A lot of the use cases, okay, I've created this machine. There's something, let's say in a dev environment, I've run something. I just want to hook into it to see what's inside in the terminal. If it just has a private IP, you can't do it, right? There's no way to route from your laptop, which is a public IP, into this private IP. There's no routes to do that. And this is where the IAP service comes in. So instead of trying to connect to this directly via the public IP of yours and try to do that yourself, the IAP service allows you to use part of the G-Cloud command to connect to a compute instance, which is the SSH command in this particular case, and then to tunnel you through into the private IP using your identity. So the thing you do every time before you can use Google Cloud, you have to do G-Cloud auth login, right? And then it pops up to the window authentication and authorize yourself. So that is connected to the IAP service, which will tunnel you into this particular place. That's how you can actually connect to this machine via SSH. So the way this works is IAP has again, this is the CIDR range we were talking about earlier. It has this range of IP addresses, right? That's the one that it needs whitelisting in order for the IAP service to work. So Google has given you a very simple way that you can basically just enable this one. So this is for SSH, which is what most people would use. The one above is for remote desktop, but it's for Windows machines. If you have, you want to remote desktop into that, that's another use case. But in this particular scenario, we'll talk about the SSH access. So you just need to run this. You can use Cloud Shell to run this as well. So once you've done this, it would look something like this, right? So you've got the allow ingress of the IAP service. Right? That's what would allow you to now use the IAP. So because the IP range is now whitelisted. The other thing you need to you need to keep in mind is the roles that you would need to be able to use the tunneling service, because what we're trying to talk about here is how do you SSH into a virtual machine that sits on a compute engine, right? And then you need to grant the tunnel resource accessor at least. So the other ones, you can have a look at the detail, how you can configure it. It's quite flexible in different kind of ways. But this is what allows you to tunnel into the machine. Okay. So there's another problem, right? So in a lot of the use cases, especially on a on a dev environment, you might actually want to have access to the internet. If you have an external IP, that's how in the old days you get rooted on a single virtual machine to get internet access. But this is actually really insecure because you end up with lots of different public IPs, and it's really difficult to control. Then if you give public IPs to the individual machines, you then have to configure the firewall rules on every single machine, which is a bit of a nightmare, right? If you think about it. So, and that's why the service of CloudNet comes in. So this is the CloudNet service I've created that applies to the network that we've created early on. So what CloudNet is, in a nutshell, is it gives you a one or multiple public IP assigned to your entire network, right? So, and then when you need to access the internet, and you would go through, through the CloudNet service to access the internet. So the individual machines no longer have public IPs. You go through the CloudNet to do it instead. But what's even better is you can actually also apply firewall rules to deny access to certain services if you prefer. So in this particular case, CloudNet gives you access to the internet. But what I've done, for example, if I'm interested in, let's say in this particular case, I've got a higher priority to give me outbound access to GitLab, right? There's a bunch of IP ranges that GitLab allows for all of their hosting service APIs and things like that, right? In this particular instance, and that has a higher priority. But then after that, I would say deny all outbound access, right? So this deny all of the outbound access from the entire network. So if let's say anyone tries to use anything but any of the GitLab services, you cannot, right? So that's going to be, I'll show you in a second what this means. So right, let's have a look what this actually looks like when you're using it. Right? This is the command you typically use for SSH into a machine. It's no different to how you normally SSH into a machine using the compute engine, but you can see there's a modifier here, which you get the tunnel through IAP, right? When I actually do this, you can see it's actually going me into the virtual machine, and it also knows who I am, right? So now this is interesting. So if the things I was talking about earlier on, the no public IP access, but I'm actually inside the machine, right? So I'm actually inside this machine in the cloud, but there's no way you can get to it from a public IP other than the whitelisted IAP service, which is managed by Google. So this is really, really good. If you think about as an organization, let's say you don't have VPNs, right? If you don't use VPN, if you don't use, any other like jump host or things like that, you have this IAP service to basically get you through all privately, which give you a really private and secure way to connect to your instances in this case. So in addition, the firewall rules I was talking about, if I let's say use try to use the GitLab.com, that works, right? If I ping the GitLab service, it also works, right? But if I try to access the Google domain, now it has. So I can't actually do it. So the CloudNet is useful if you need internet access. You can also block the services or areas you don't trust, or you just basically only whitelist the things you want to trust when you have that option. So right, this actually get me into the machine. So what can I do with this? Well, there's tons of things you can do with it. One of the things I used to do a lot in the past was basically tap into a service. So that could be a let's say the Cloud SQL service to explore what's inside that database. Because if you just use a command line tool in here, right, that would be a bit of a nightmare to try to look at what's in the database. So everything you need to kind of type in those commands. So this is where it gets interesting. So one of the things you can do is to port forward the Cloud SQL database service into your local machine via this tunnel. So I'll show you what that actually means. So in here, I've created a private MySQL instance on Cloud SQL. So again, this is another interesting one, right? So when you're creating a Cloud SQL instance, you really don't want it to give it a public IP, right? If you give it a public IP, you open up all sorts of security risks from the SQL instance itself. So instead, what you do is you basically just create a private one, right? This is the private instance. There's no public endpoint whatsoever. It's all locked down in your network. But how do you actually get to this, right? If you want to run some query on this database, if you want to explore the tables in this database, how do you actually do that? So this is where the IAP tunnel comes in. So note down the IP address 10.1.0.3, right? And then what we'll do is we'll connect to this database via the IAP tunnel. So now I've prepared another command here. So it's the same thing to tap into the compute engine. Because the compute engine instance I've created is in the same subnet of the same VPC network of the Cloud SQL instance. So the firewall rules are by default open because it's all private in there and all internal. So there's a SSH flag option, which is where you can do the port forwarding. So this is the local port forwarding I've done here. If you haven't done this kind of thing before, what this means is you would forward the 10.1.0.3, which is our SQL instance, on the remote machine, right? The remote machine is basically the ones you're connecting to. The private instance one machine sits in the private network. On port 3306, which is the MySQL port on Cloud SQL, right? This is the service that runs on that database. And you want to forward that to the local host of my machine, right? This is my client machine. This is my laptop. I've got 13306. I typically don't like using the same port because sometimes very often I run my SQL database on my laptop as well, right? And then it's just quite dangerous because when you do this kind of things, you don't know where it's coming from. So I typically give it a prefix of a 1 or 2 or 3 or 4, right? Then it's not something that you run locally. Once you establish the tunnel, right, this is where it gets interesting. Right now I'm connected to this machine. So locally, if I run this, right? Right, you can see the port is now open. So I don't have anything runs locally on my 13306 spot, but this still works, right? So that's how it actually tunneled and gave me access to this Cloud SQL instance. But the port is actually running, the service actually is like it's running on my local machine. So finally, what I can do is, if you look at this thing, right? So this is data grip. You can use whatever that SQL client you want to use. So basically what I'm doing here is I'm connecting to this Cloud SQL instance because it's the MySQL one. So it has the MySQL protocol and MySQL ports. So localhost, this is on my machine, port 13306. I've got the credentials in here. Just note that usually in the client, you have an option to set this to read only. Obviously, the better way to do this is always make sure when you grant the user access, especially if you actually do this for the UAT or production environment, make sure you don't give write access, right? Because people usually do this. The reason they do this is for debugging, because it's the easier you kind of you look at the database, the closer you can use this tunneling to get really good visibility in those IDEs, in those SQL clients. But you don't really want to modify things, right? In almost all of the times, at least not in those tools, because it's quite dangerous. So not only you want to restrict access on the user level, but also most of the time in those IDs you got this read-only option as well. So when you tick that, even you do have write access, you can't do it, right? You need to tick this off before you can change the database. It's a good thing to do, just in case if you're actually messing around with production systems. And then look, test connection. Okay, just want to rewind a little bit. So the earlier when I said I apply a firewall rule on the outbound access, so that is actually outbound. Totally forgot. It's not just outbound for the external network, right? It's outbound for everything. So when you say deny all in the outbound, I've also denied the SQL, the cloud SQL access. So what I have to do is to open up the egress access to the SQL range, which is in the 10.1. So is in this range, in the 10.1.0.0/20, right? So that's where it's been created in this range. So now, if I now go into the connections, you can see now it's successful, right? Earlier it's failing because it doesn't have the egress connectivity from the virtual machine, from the computer engine virtual machine to the Cloud SQL machine. Right now it's opened up. And then, so you can see in here, I'm now connected to the SQL database. I can look at the information schema, right? I can look at the, anything else in here. So this gives me access to the Cloud SQL database with no public IPs whatsoever. So this is extremely powerful stuff. So if you imagine in an organization, you have a lot of developer engineers, right? So how do you protect the boundaries and to allow, these accesses only ever go privately, never go publicly? And that's how you can do it. Okay, this is the end of the session. Hopefully you find this useful, and I'll see you next time.
Go out!